All right, welcome back, everybody. It's 10. It looks like most people are here. So I'm going to go ahead and share my screen. I'll be working through the string reverse re-implementation, and then in a minute, Brian will talk to you all and work through the flatten. So as I'm looking at this problem and we're thinking about this in like the context of these challenges that can be part of technical interviews, what I've already done is I've just gone ahead and created this Ruby file like the instructions said, and I'm going to start by just pasting the instructions here so that they're, so that they're very accessible to me. And at this point, what I like to do is start thinking about my kind of action plan at this point in like an interview or, pairing with somebody or having them observe, I might ask some clarifying questions about the problem. And I've looked over this and I don't necessarily have too many clarifying questions this time, I don't think, but I am going to notice that we should be able to make spaces work, thinking about some edge cases. One thing that comes to mind is what if it's just an empty string? Can we still run this file and get a result if we don't put any actual characters in there? Is it going to work with special characters like symbols or integers or numbers inside the string? So as I'm looking at these instructions, we've already done this, the creating a file in a folder using TouchReverse. And I'm in that file. So the first thing I'm looking at here is write a method that will take a string as an argument and return the string reversed. And it even, we even have some examples of the type of code we could use here. So I'm going to uncomment this method that was suggested, as well as the method call, the puts my reverse. The next thing that I think is probably worth mentioning for my process is I tend to really rely on pry as a debugging tool. So I'm going to preemptively require pry just in case I need it. And I'm going to just give myself a little space to work here and start writing some pseudocode. So in my experience interviewing and having challenges like this, kind of, on the spot writing code with somebody, it's kind of manifested in a few different ways across different interviews and companies for me. Sometimes it's just a whiteboarding exercise, and the idea is to put some pseudocode on the board and explain the thought process. And sometimes it's a complete implementation. I've had interviews with various levels of collaboration. So it just kind of depends upon how the interview is going and kind of what it seems like the person that you're working with is expecting. But typically how I would start would be by just writing out in plain English what I want this method to do in any of those cases. So the first thing is I want to take this argument, this value here, and look at these characters one at a time. And then I'll think about reversing them. So I'm going to write that here as a comment. Look at the string one character at a time. And then I'm thinking for the first implementation, I'm probably going to be starting by setting up a new array to put the results in. So I'll just write that here as well. So I'm looking at the string one character at a time, and then I'm assigning a local variable with an empty array. And then I think there are a couple of ways to approach the actual reconstruction of a reverse string. And what's kind of coming to my mind is that we could like each over it, we could map over it. And I thought about kind of those options as I'm just writing pseudocode, but I think what I would like to do is just look at the string as many times as there are characters, and then grab the character and put it in the new array. So if I'm breaking that down to like the smallest steps I can imagine, I would create the new empty array and then grab the last character and until the original is empty, I guess is how I would communicate this. And then this might actually be 2 lines here as I think about it, because I'm grabbing that last character, adding it to the new array, and stopping when I don't have any more characters to do this with. So I'll kind of indent those to communicate to myself like, this kind of looks like something I could do in a block. And then we're adding something to the new array. So presumably we're going to have to join the array back together at the end. So I'll say join new array into one string, I'll specify one new string. And then we might not need this explicit return, but we are going to need to return that new string. At this point, I think it's a good process point to just kind of go through the pseudocode and make sure that the logic lines up and that I can't think of anything that I missed. I think this is typically, if you're going on to like a full implementation, I like to take this time to talk about the proposed solution a little bit. And in some situations, like with some of these problems, you can get some really good feedback just by asking, hey, this is what I was thinking. Do you see any problems with this so far? Or would you recommend doing it differently for some reason? But yeah, I'm going to look through this and just say, okay, yes, I know my code goes here. I'm looking at this one character at a time. I'm setting up a new empty array. And last character, and I'm going to specify of the original string. I'm going to grab the last character of the original string and add it to the new array as many times as I can until I don't have any more in the original string. And I think that implies, see, I'm glad I stopped and looked at this because I think I missed a step here. I'm going to need to first grab that last character of the original string and add it to the new array, but then I also need to take that character off of the original array. And really by now this is probably an array because I want to be looking at these one at a time. So I'll say array, grab the last character of the original array, add it to the new array, and then remove it from the original. And I think I'm pretty happy with this. So at this point, I'll start thinking about what this looks like in code. So I should be able to do, I think I'll assign this to original as a variable, and I'll say string dot, I believe it's split. And if I pass it an empty string, that should just split it into an array. And at this point, I think what I'd like to do is just go ahead and run this file and see what this my reverse method is returning, so that I can make sure that every step of the way I'm getting what I expect. So I'll say Ruby reverse. And this is what I expected. I have basically an array printing out, each of these characters. And if I were to go ahead and put my binding.pry in here, I would maybe see that more accurately, like see that this original variable is holding an array. So I feel good about that so far. I've done this first step. I have access to every character, and I read this note that I have to myself, looking at it one character at a time to me says iteration. So I'm kind of starting to think about that. But I have another really easy step I can get out of the way first. I can say reversed and set that to a new array. And as I'm looking at this, I'm thinking, I need something that can iterate over a collection, and I need it to return a new array. And that makes me think of map. But I think it's a good idea to just work through the notes I have here and then maybe refactor at the end if I have time. And that's something that I would also, want to communicate to whoever I'm collaborating with, just to make sure we're all on the same page. So now I'm at the point where I can think about how many times I want to iterate. I've considered map. I kind of want to save that for maybe a refactor. I think here what might work really well is to just go as many times as we have characters in this original array. So I'm going to say something like original length, I can spell, times do, and I don't think I need a block variable here, but my idea is that I will be going through this block as many times as I have characters. And at that point, when I'm inside of this block, I could say, I want to shovel something into the reversed array. And I think that would be the last character of the original string. And I could get that by saying original. And then get the last element by using -1. And I'm going to move some of these notes. I think they're more accurate actually inside this block. So let me do that. So I have this part where I'm adding it to the new array. And then removing it from the original, I could do original.pop. And until the original is empty, that should be taken care of here. But I think this is probably a good point for me to run my code and just see how close I have gotten. I get 5. So what happened here? I have this going through, but I'm not specifying what I'm going to return after this. It's just kind of returning whatever the return value of this block is. And we have 1, 2, 3, 4, 5 characters. So it's saying, oh, I'm doing this 5 times and just returning 5 as our value. But hopefully by this point, reversed is holding the new reversed string in the form of an array. And I can return that by making it the last thing in the method. So let's do that again. And we're getting closer. This is kind of starting to look like what we want. Now we have this similar output of an array with the characters going O, L, L, E, H. Okay. So I think I'm going to go ahead and just to clean this up a little bit, get rid of some of the notes that I feel like I have attended to. Assigned a local variable. Yep. Grabbing the last character of the original array, adding it to the new array. And I think that actually we could probably simplify this line before I move on to more. Well, I guess I should actually get this joined, but I do want to like leave these here to remind myself to come back and see if I can replace this original bracket -1 with just the original .pop. I think that'll give us the same result. But for the time being, we do need to join this array into a new string and then return that string. So I'm going to, instead of just returning reversed, I'm going to try saying reversed.join. And I believe I can just do the same thing I did with split. I don't remember off the top of my head, but let's try it. And there we have it. We have our reverse string with the example value that we were given. So let's see, I think this is a good time to maybe try this. My theory is that original.pop will just take that last character from our original array and take it away from the original array, and it will also, the return value of pop is also the last character that you're popping off. So theoretically, the shovel operator will take that and put it into the reverse array at the same time. Looks like that works. So now I think I'm at a really good point with just this plain string hello. And now we can test a few other things. We thought about like what happens if it's all like empty space. Does that work? It doesn't blow up, and obviously can't really see what it's printing out because it's empty. Hello world. Does it work when there are spaces between the characters, and will it accept, you know, a special character like an exclamation point? That looks good to me. And just to be sure, I can just throw in a few other, you know, nonsense strings, and it looks like it meets all the conditions that we were asked to implement. So I feel pretty good about this. The only thing that I would add to, or that I would clarify about my process as I was looking at this problem is I did read the problem probably 3 or 4 times before I even created this file. And that's probably something I should have done as part of this process, just reading the problem, being really, really clear on what the expectations are, and asking any questions before getting started, or even before continuing down a path when I saw errors or got stuck. That's a super important of my process and has really helped me out as I do these kinds of challenges and interviews. It can create some space for conversation about these solutions and also just save me some time and pain if I did miss something. Why convert to array can iterate through string. So that might be something that I would consider, that might be something that I would do as a refactor. So let's try it. I don't want to take up too much time, but it's only 10:15. I think we can look at a couple refactors. So let's think about iterating through the string instead of making this into an array and putting it back together. If we have our string here, we can call length on string. So I could potentially do string length times do. And then I wonder if pop will work. I think that's just an array method, but we can, maybe what I'll do is put a binding.pry in here somewhere just to play around. So string.length. How about string.pop? Yeah, pop looks like it's just an array method. But if I could maybe do, I don't think we have like a, this might be a good time to go to the Ruby docs though, if that's, and that's, you know, if that's something that's permissible in the context of the challenge. I think kind of depends upon what type of interview, what type of company. Let's see, I was going to go to Google the Ruby docs, string methods. I guess I should bring that onto the right screen. And I could definitely Google like get the last character of a string in Ruby, but maybe it's worth looking at a few of these or even just searching on the strings page, like last returns a new string with the last character removed. That's chop. Applying chop to an empty string returns an empty string. And this actually reminds me of something that I'm going to take a quick detour for. I don't know if I tested the working method that we have with an empty string and no spaces. So I just want to be very thorough and make sure that that works before moving on. So I'm going to exit out of my pry and then run this again. Cool, so we're back where we started. And if I give it just an empty string, it gives us nothing back, which I think I think that handles that well. Could probably make it better by returning a different message if the string did not exist or wasn't reversible, but I think that's probably beyond the scope that we're looking at. So chop doesn't quite look like what I'm looking for. It seems like it's giving back everything except that last character that I would need. The last form returns a copy. Yeah. Our index returns the integer index of the last occurrence. Yeah, I'm not really finding much of what I'm looking for. So in like an interview process or a, a challenge where I'm collaborating with somebody, I'd probably just even ask like, hey, do you know of a method that would allow us to get the last character of a string? Maybe they would answer, maybe they wouldn't. So let's see, it returns a new string with a given record separator from the end of string. So we can say hello chomp, hello. So I guess theoretically we could maybe use chomp and pass it like something that we know is in the string. I'm not totally convinced.
I could try to point you to something. I don't know if it's going to work, but look at the method for the brackets.
Like the bracket notation that you would use to get
exactly
the last part of an array, right?
Yeah.
So it looks like string index, new string or nil. When the single integer argument index is given, it returns the one character substring. That's great, thank you. So it seems like that works very similar to how we were using it with the array. And I wonder if we could kind of go back to, let's see, let me think through this. I'm trying to think out loud and type at the same time. So before we moved that original .pop like into a one-liner, I had something where it would first put that last character into the new array, and then it would remove it from the original string. And I actually kind of, now that I'm thinking about it, I'm thinking back to that chop method that we were looking at, because it will return a new string with the last character removed. So we could manually remove that last character, or we could just say original.chop. And let me double check and see. I think maybe we have to, I'm wondering if I have to add a bang to the end. Chomp is a safer alternative as it leaves the string unchanged if it doesn't end in a record separator. I think in this case, we do want a destructive method. We really do want to remove the last character in the original string. So I think I want to read through this one more time, make sure I didn't miss anything, and then try it. I'll run it. I'm gonna comment that back out. We're not using it. We have a new array. String length times do. Yeah, let's just try it. Oops, what'd I miss? Yep, I'm still using original. Ooh, that's not what I wanted. So this is where I would probably make use of my pry. And I just want to look at this one step at a time, and hopefully that'll show me what I missed. So I have reversed. I would expect this to be an empty array. If I do string -1, I get the O, and then string.chop. What if I ask for string now? So it did not actually change string, the value of string. I think maybe, and speaking to my theory earlier, that seems to do what we want. And theoretically, what was happening here was the string.chop without the bang was not destructive. So every time it came through this loop, it just found O as the last character. And we ended up with O for our new string. So let me just exit out of this. And we get back into the loop and see that the string has the last character removed. So I'm going to exit again. And that's not quite what I would expect. I would expect an L to go away. So I'm going to keep exiting. And now we have kind of like recreated this problem with a different character. And that might be, I'm just going to rule out the possibility that that happened because I didn't exit my pry after making those changes. And that's exactly what it was. It only kept track of like the thing I typed into the terminal. But now we have it returning our string in reverse. Reverse needs to be an empty string. Yep. So now that we have looked at getting rid of this original string split array, now could we make that into an empty string and hopefully only need to return reversed? That's kind of my theory about how this would work, but I'm prepared to throw a pry back in and troubleshoot if I missed anything. And it looks like that was a super easy refactor. We just got the same result back without needing to turn any of these into arrays. We just use them as strings, like the suggestions. Thank you for those suggestions in chat, by the way. Let's see, 1024. I think maybe what I'll do is talk about other, like I'm just gonna speculate out, like think out loud real quick about other things that could maybe make this better. I don't necessarily know if I should take the time to implement them, but I think we could absolutely do this with a map because we were returning a new value based on like input from the original value that we're getting here in our argument. I could also maybe go back to the Ruby documentation and keep looking for methods that would do these two lines more efficiently. Nothing immediately comes to mind, and I haven't really used chop a lot, but that's another thing that I could potentially spend time on. But yeah, I think I'm pretty happy with this overall for our 30-minute review. And I guess I'll open it up for any questions about this problem. And after that, we'll turn it over to Brian to look at flatten.
While you are thinking of those questions, one thing I wanted to point out was that when Jameson was talking about like going to the docs and looking at things and Jameson said like, oh, maybe like an interviewer would help me. When you're doing these technical interviews, what is most important is your process. Like 99% of the time, the interviewer is not looking for you to necessarily get the right answer. They're looking to see how would you work through a problem. So if if Jameson got to that point of like, I wonder if there's another method, and said like, well, I need to do it with like just what I can memorize. Me as an interviewer, I might say, that's not really a great process. I really want to make sure that this person like can handle things that they don't have memorized, that they don't necessarily know how to do. And so me as an interviewer, just Jameson describing, I would go to the Ruby docs, and specifically the string Ruby docs tells me, oh, this person knows how to find the information that they're looking for. They're trying to call a string method, so they would go to the string Ruby docs. That's all like a very valid process there. So even if you don't necessarily like get the right answer, or you're not getting to the right answer, you need to think about like, what are you showing at any given point in the interview? And usually you want to show that you can work through adversity, be resourceful, ask good questions. That's really what we're looking for in an interview.
Well, I see somebody asked if I could do hello with an empty space at the start. Thank you, Joey. So I included this, and what's interesting is we can't necessarily tell if that space shows up at the end. But I suppose if I put like another character in between, we could confirm that the space is included, and it looks like it is. At the end to see the space at the end. Yeah, let's see. Try it both ways. I think that's valuable. And here we see our ole is indented because it's including the space at the beginning. Okay, if nobody has any other questions, I will stop sharing.
So I think let's go ahead and take a palm, and let's come back at 10:33, and we'll work through flat. All right. So let's go ahead and pick it back up. Um, I mentioned a little bit about process in the beginning, and Jameson definitely did a great job of talking through their process as Jameson was working through that problem. Something that I'm completely going to steal from Jeff if you don't get to hear this directly from him. When Jeff talks about process, he likes to talk about this idea of aviators flying a plane and their process for when something doesn't go wrong when they're flying a plane. So you're a pilot, you're flying a plane, something's going wrong, and of course, like you're terrified. You're in this fight, flight, or freeze mode. The plane might go down. You've got people's lives at stake, and so like it can be very difficult to follow. It can be very difficult to solve a problem while your body is in that like fight, flight, or freeze mode. And I think that oftentimes we get into that same mindset, or maybe not mindset, but we get into that same physical state when we're in these interviews. So these interviews can feel very high stakes, very much like, even though it's not, it can feel like life or death. And so we're in that similar fight, flight, or freeze mode. So when pilots are flying planes, this is an example of their process, and it's a very simple 3-step process. It's aviate, navigate, and communicate. So number one, when you're flying a plane, something goes wrong, keep flying the plane. Number one, make sure that you still fly the plane. You don't want to go off and like try to fix a problem and then realize that you created another problem by just not attending to your job of flying the plane. So very simple, it might seem very simple, but aviate, that's just a very simple word I can keep in my mind. The second thing is navigate. So not just fly the plane, but try to figure out where you're trying to fly it to. And then the final thing there is communicate. So talk to other people, bring other people into the process. So if you didn't have this process in your mind, you might immediately go back and try to fix something in the engine. And meanwhile, there's someone on the other line who can help you out if you would just communicate a little bit more. So this is an example of a very simple real world process that is used by pilots. So this is an example. So how does this relate to what we're talking about in interviews? It's not necessarily important that you have the right process. It's not necessarily important that you all have the same process. It's not even important that you have the same process that the interviewer would use or a process that the interviewer would really approve of. What's important is that you have a process. So here at the end of Mod 2, as you're moving into the second half of your Turing journey, we really are going to start thinking more about interviewing, getting the job, and along with that comes your problem-solving process when you're in this very constrained, confined environment. So I want you all to start thinking about this right now. What is part of my process? What do I want to include? What did I see Jameson do that I think that I need to keep in mind while I do this? So I wrote down, we've got some things here that you can include. Now, again, this is not like this is the right process and you all have to use this process, but these are just some things that I think are really good. So Jameson mentioned this, but like read the problem and read it multiple times. Ask questions, ask the interviewer what resources you should or can use. Definitely ask clarifying questions about the problem. So like what input is expected, what output is expected? Is there a certain technique that I'm supposed to use? Articulate the big picture. I would say like kind of keep your eye on the prize. Actually, that's what I wrote right below it. Ask for feedback. So you can ask the interviewer, I made this solution. Is this the most efficient way to do this? So in Jameson's example, maybe the interviewer says, actually, the array pop method is not very efficient. Could you find a way to keep it as a string? And then they would work through that. Collaborate. I think this is very similar to ask for feedback. Talk out loud, narrate your process, write down notes. I think comments are a great way to do this. Pseudocode. We saw Jameson do this. Jameson did a lot of pseudocoding before they even started the problem. And then start with a small test and work your way up. So these are all some really good ideas. If you have a process, I don't think I would want it to be like 11 lines long. For me, I think the most important ones that I include are make sure I'm reading the problem, make sure I'm asking clarifying questions, and make sure that I am pseudocoding. This is all things that I need to do just to slow myself down so I don't just jump right into the code. If you saw Ian's fireside chat a week or two ago, that was last week, one of the things that his interviewee mentioned was one of the biggest red flags they see is when people just start coding too often, or sorry, coding too soon, too early. Okay, so that's a little bit of like general background. And now I want to get into recursion. So recursion is a topic that we don't really cover in any part in Turing, like very in depth. It's something that you would probably study a little bit more in depth if you were doing like a 4-year computer science degree. So we're going to talk a little bit about it now just to give you some exposure. And it's something that you might get into more, especially if you get into functional programming languages like Elixir. Those really use a lot of recursion. So yeah, I'm going to use recursion to solve this flatten problem. So recursion is when a method calls itself. So I'm going to move these notes over here. Let's actually do it like this. There we go. So recursion is when a method calls itself. So if I'm trying to implement flatten, I might call it like my flatten. And this is going to take a nested array. So I'll just label this variable nested array. Essentially, all I need to technically do recursion is call the method inside the method. So let's make a couple test cases. So let's say test1 equals. So what this would look like is a nested array, something like this. And so what I would be trying to get back would be an array of 1, 2, 3, 4 without any of these subarrays in it. So I would say this array is nested one level deep. There is one array, and then there's an array within the array, and then there's another array within the array. So it's one level deep. So what we're looking to get back from this is an array of 1, 2, 3, 4. So if I just call my flatten as it's written right now, this method calls itself. And so then it would execute this method, which would call itself, and it would execute the method, which would call itself, et cetera, et cetera. And I think you can see where this is going. This is going to create one of the most fun problems in computer science, which is an infinite loop. I've created an infinite loop, and we can see trace back most recent calls last. There is, looks like 11, almost 12,000 stacks on the stack right now. And so this is going to give me a stack level 2 deep. So essentially it is like, my memory is like billowing up as it's trying to keep track of all of these recursive calls. And eventually I just run out of memory. So I get a stack level 2 deep, which is a Stack Overflow error. So that's where the name of the website comes from, Stack Overflow. So yeah, if I just have a recursive call, then I'm going to run into an infinite loop. So recursion is when a method calls itself. We want to avoid this infinite loop. So we're going to need 3 things for that. The recursive call is the number 3 down here. That's the one that I've already included. The most important, or a very, very important thing to think about as you're recursing is, how do you know when you're done? So I can infinitely loop by just like calling my own method, but how do I know when it's done? So essentially, how do I know when I've achieved this output that I'm looking for? Something that I didn't put in my notes, and I kind of want to put it in there right now, is like a common question is like, how do I know when to use recursion? And problems that lend themselves particularly well to recursions are problems that can be solved by solving subsets of the problem. So for example, this problem of flattening this array is essentially doing the same thing, flattening the array, but in smaller and smaller increments. So flattening this entire array is the same thing as flattening this array and then flattening this array. So that's what I mean by there are subproblems here. If we nest another layer deep, so let's maybe actually make this, we'll do it like this. So now we're nested 2 levels deep. We've got one outer array, then we've got another array inside that array. And then in that subarray, we've got this array that's inside that array. So solving this problem, let's call this test 2, would be flattening this whole array would be flattening this subarray, and then flattening this subarray would be skipping this one, and then flattening this subarray. And then if there was another subarray, I would flatten that one. So anytime you look at a problem and you see like smaller and smaller subsets of the same problem, that is a good use case for recursion. Contrast that with what we did with reverse. There's really not a sense of like a subproblem there. It's not like you're reversing multiple times. You're really just reversing once, and you have to do one big iteration to do that. So the opposite, usually there's 2 like strategies for approaching a problem: iteration or recursion. So we're seeing one example with reverse, one example with flatten. So that's how I know that this is a good use case for flatten. So I essentially have to write code to break this problem down into smaller and smaller subproblems until I hit this base case of how do I know when I'm done. And then the last thing that we haven't talked about for recursion is that you need to change the input to the recursive call. So if I just made a recursive call like this, if I called the method with the exact same input, it would just do the same thing over again, and it would just get caught in that infinite loop. So I need to make sure I'm doing these 3 things. Okay. So how am I going to solve these subproblems? Well, if I'm going to be given one big nested array, I'm going to need to look through, and here's where I'll start pseudocoding. I'm going to look at each element in the array. So if that element, so if we happen upon an element that is an array, then we're going to need to flatten that array. But if the element is not an array, we're going to need to probably do nothing, or maybe add it to the return value somehow. This one's a little bit trickier here, but we'll cross that when we come to it. So we're going to look at each element in the array, and I'm doing a very similar to what Jameson is doing. I'm trying to like describe in English how I would solve this problem before I even start writing code. So look through each element in the array. If it's an array, we're going to need to flatten that array. And then if we happen upon an element that's not an array, like a 1 or a 2, then we can just make sure it's in the return value. But if we happen upon another nested array, flatten. Okay, I'm feeling pretty good about this pseudocode. I think that will get me to where I want to go. I think I've included all 3 things for recursion. So my base case is if the element is not an array. So maybe I'll just write that here. This is my base case. Change the input. I am doing that right here. So changing the input. So I would be calling the same problem, but with a different array, or sorry, the same method with a different array. And the recursive call would be, I guess, right here. Calling the flatten is my recursive call, but I need to call it with a different array. Okay, so I think I'm ready to start coding here. I will do, this is the first thing that stands out to me. I'm going to need to do a .each over this array to get each element out of here. So that was my first thing. I think I can take this line out here. So I'm looking at each element in the array. So maybe I'll just put that right here. And now for each of those elements, I need to do this. So maybe the first thing I can do here is just puts each element. And one thing that that we could do here is we could do P. So I think this could have come in handy for the last challenge for the reverse, but P is a very helpful way to print something out. But if you don't want it to be human readable, you actually want it to print as a Ruby object, this can be very helpful. So watch what happens. I did something wrong. Syntax error, line 13. Is it one of these lines? So when I'm hunting down syntax errors, I just like to comment out the lines that I think might be giving me trouble. So was it that line? No, was it that line? Yeah, it doesn't like this line. I'm guessing it doesn't like the spaces in the array. My best guess.
No, Brian.
Oh no, I'm missing a bracket. Was that it, Olivia?
Yeah, that's what the chat said.
Yeah, I was missing a bracket there. There we go. Cool. Now let's try to call my flatten. And now we can see when I use the P statement, it prints it out, but it prints them out as arrays. So if I contrast that with puts will print out all the elements, and then it's like kind of confusing what I'm actually looking at here. Okay, so this is going to give me access to each element in the array. And for my first test case, each of those elements is a nested array. Now what I want to do is I want to do my if statement. So if I'll say element.class equals array, and I think there's better ways to do this. Let me actually just do a quick Google here. Ruby check if something is an array. Kind of, yeah. Is a instance of, what does kind of do? Returns true if the class is a class of object, or if the class is one of the super classes of object. What does is-a do? Returns true if the class is the class, or if the class is one of the super classes or included module. And it gives me some examples. Okay, cool. I don't think this is exactly what the point of this challenge is. I think is would be just fine for this. So I'll say is a array. This would handle like cases where it's a super class, but anyway, we'll move on. And I'll just write off my else and my end. Okay. So if the element is an array, here's where I'm going to need to call my flatten reverse. So here I will call, or sorry, my flatten with my changed input. So my flatten with this element. So if we found an array within an array, then we'll just flatten that subarray. Otherwise, I think we just do nothing. We need to somehow add it to the return value. So let me move my comments around this. Like that. Cool. So now I need to figure out how do I track this return value. So if my flatten, if this is going to return to me the flattened array, what do I do with that? So I think what I want to do is I want to keep track of a, I think I want to keep track of a return array, or maybe maybe this is like flattened array. So I need to somehow keep track of the array that I'm going to return. And I think I need to actually put this outside of my each. So if I put it inside the each, it would create it every time this each ran, which would be for each element. I want to create it once. And so then if my flatten is going to return to me an array, I want to add that flattened array to my already flattened array. So what I might do here is I might just jump into pry and test out a couple array methods, because I think to add an array to another array, I think I want to do plus equals like this. No, that's not exactly it. What about plus? Plus worked. It just didn't like plus equals. Okay, I think that should be all right. Could I shovel in another array? No, because that just adds it nested. That's not what I want. And I think dot push would just do the same thing. So it allows me to do plus. I'm surprised that it doesn't let me do plus equals. Syntax error. Interesting. Oh, I think I know what it is. If I save it to a variable, maybe 1, 2, and then x plus equals 3, 4. Yeah, that will work. Okay, plus equals is the right thing here. Okay, so to add an array onto another array, I should be able to say flattened array plus equals my flatten. So if my flatten is going to return to me an unnested array added on to my flattened array, but if it's not a nested array, if it's just a standalone element, I think I can just shovel it in to that flattened array. And then at the end of the method, I would just return back flattened array. So yeah, let's see how far that got me. I'll do a P statement at the end of my flatten down here. And that looks like it worked on the first one. Let's see if it does test case 2. And it did work on that one. Let's see if it handles just like a plain old array. Oops. So will empty array return me just an empty array? It looks like it does. What about a just already flattened array? That looks like it works. What about an array of one element, like maybe just a 1? That also works. And now I think what I want to look at is, this is probably going to be the real test. Like I'm going to make something that I can't even like really keep track of how nested it is. And I might run into another issue where I have brackets off. And now I'm going to include like some empty arrays in there. Oh, that's probably another good test case. Let's see if we can do a test 6 with like an array of empty arrays. And like, how deep can I go in here? Yep. So now no matter how many empty arrays I put in here, it's still flattening all of them. Okay, so now back to my test 6. This is the real big test here. Oops. Just like really going for it. We'll change this one to test 7. And I think that's it. 1, 2, 2, 3, 4, 1, 5. Yep, looking good. Okay, so that is my solution to my flatten. I've got a couple minutes here. Yeah, what does anyone have any questions? I think that's about everything I wanted to talk about here. What I would recommend if you want to like learn a little bit more about recursion, or really like just kind of wrap your head around this, because I think it's kind of it's really brain bendy when you first see it. If this is the first time that you've seen it, what I'd recommend you do is you try to follow through this code with a very simple example of like, maybe even this one is too much. Maybe if you change this to like something like that, even simpler, where we just have 2 subarrays and one of those subarrays has three elements. Really try to follow through the code what's going to happen, and you'll run into this point of like you go forward to work through something, but then you realize once you get to the end of something, you actually like end up going backwards. And so the directionality of recursion is just like really tough to wrap your mind around at first. Any questions coming up about this? What I will leave you with then is my experience of the interview that I did to get my first job. So it was the challenge was to do the Fibonacci sequence. So the Fibonacci sequence is where every number is the sum of the previous two numbers. So we start with I think it's 1, 1, and then 1 plus 1 is 2, and then 2 plus 1 is 3, and then 3 plus 2 is 5, and then 5 plus 3 is 8, 5 plus 8 is 13, 13 plus 8 is 21. And so every new number is the sum of the previous two numbers. So as I solved this problem, I said, okay, well, this is solving the same problem over and over and over again until you get to, you know, your base case, which is essentially how many times do you want to do this? So it was like, do we want 4 Fibonacci numbers, which would be these first 4? And I think 0 might be one of them, but it doesn't really matter. Or do you want 8, which would be all 8 of these right here? Or do you want it to go up to 100 numbers? And so I asked the guy who became my boss, I asked him, do you want me to solve this with recursion? Because in my mind, oh, recursion is like more challenging. And that's like probably what the interviewer wants to see. And I was very surprised to hear him say, I just want you to solve the problem any way that you can. And so recursion is something that you can study and implement. And I think it is like very helpful in certain cases, but recursion is not always the right answer. So really what my boss wanted to see was he wanted to see me given a problem and just work through it how it made sense in my brain. And when I thought through it, recursion didn't really make as much sense to me. And so I didn't solve the problem with recursion, and that was totally fine. So that's a little bit of my experience. All right, y'all, I'll go ahead and wrap it up here. Thank you very much for your time. You've got those PD groups in the afternoon. I am going to keep your eye out on the Slack channel. There will be an attendance thread, and the rest of the afternoon will be work time. So if anything comes up, if you need any help, feel free to like reach out, and we can help you troubleshoot things as they come up. All right, y'all, have a good rest of your morning.